Using elementary transformations, finding the inverse of the given matrix. Suppose this is a general matrix which has the elements A11, A12, A13, then A21, A22, A23, and A31, A32, A33. As a first step, make sure this leading diagonal element is non-zero. Suppose if the leading diagonal element contains 0, we will interchange two rows or two columns so that the 0 not present in the leading diagonal element, that is A11, A22 and A33. So first step is we have to make sure A11, A22 and A33 is non-zero. As a second step, take A11, concentrate on this and make this as 1. So we have to make this element as 1 by division. So whatever the element present here, we will divide. Suppose this has 2, then the entire row should be divided by 2. And after making A11 as 1, the elements present below, that is these two, we have to make it as 0 using the one which we created, that is using A11. So make A21 and A31 as 0. For making 0, we have to always use either addition or subtraction by making use of the one which we created. And the same procedure can be followed for the next column, that is make A22 as 1 by division, and using that one make A12 and A32 as 0. So let me write it here. Make A22 as 1 by division, and what are the elements above and below, which is A12 and A32, that we have to make it as 0. In the same way, we can make A33 as 1, and after making that as 1, make these two as 0. So I will complete the step here. That is the third diagonal element. Make A33 as 1 by division, and after that the elements above, which is A13 and A23 as 0 by addition or subtraction. So this is the general step. So once if we follow this, we get the inverse. So let us follow the step for the given matrix. That given matrix is the elements 1, 3, minus 2, then minus 3, 0, minus 5 and 2, 5, 0. So here we have to write A equal to IA. This is the first step. Then copy the given matrix A, which is 1, 3, minus 2, minus 3, 0, minus 5, then 2, 5, 0. And I is nothing but the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And we will write A as it is. Now, in the steps which we discussed, I told leading diagonal elements should be non-zero, but we find two zeros here. So as a first step, I am going to do R2 and R3 interchange. So by doing so, just to see what happens, first row 1, 3, minus 2 will be as it is. Then row 3 will come in the place of row 2 and row 2 will come in the place of row 3. So whatever the row operation we do here, it should be done for the other matrix also, where again we have R1 as it is, then R3 is coming in the place of R2 and R2 is coming in the place of R3 into A. Okay. As I gave the general steps, now we have to concentrate on this element, and this is already 1. So we can skip that step and go to the next. The next step is making these two as 0. That can be done if I take R2 gives R2 minus 2R1. See, making use of the 1, and by addition or subtraction I have to make 0. Similarly, R3, both the row operation can be done in the same step itself. R3 gives R3 minus plus 3R1. So this will become 0 now. See what happens. Row 1 we are not doing anything, so 1, 3 minus 2 should be written as it is. Then if I do R2 minus 2 times of R1, so I have to take R2, that is this 2, and this 2 times of the row 1 element, if I subtract, I will be getting 0. So in the same way, if I do for 3 and 5, that is 5 minus 2 into 3. So I will write it here. I am following R2 minus 2R1. So R2 element is what? 5 minus 2 times of R1 element is 3. So if I do so, I get minus 1. In the same way, 0 minus of 2 times of minus 2. So that will give 4. So row 2 I finished. Let me complete row 3. So what is row 3 here? I'll write it again in the rough. That is row 3 plus 3R1. So this is 0 anyway, because minus 3 plus 3 times of 1. Then for the next one, it is 0 plus 3 times of 3, which is 9. In the same way, minus 5 plus 3 times of minus 2, which is minus 11. So whatever done here should be done for the other side also. If I take row 1, there we are not doing any row operation, so 1 0 0. Then for the row 2, it is actually row 2 minus 2R1. So if I do that here, 0 minus 2 into 1, which is minus 2. Then this is going to be 0, this is going to be 1. That is 1 minus 2 times of this. And similarly for the row 3, 0 plus 3 times of 1. Then this is 1 and this is going to be 0. And this is A. Then after this, I told we have to concentrate on the next diagonal element, that is this part, which is A22. How to make this as 1? R2 gives R2 by minus 1. I told create 1 using division, create 0 using addition or subtraction. So now, if I divide the entire row 2 by minus 1, so row 1 I have to copy as it is. This is going to be 0, 1 and minus 4. And R3 we are not doing anything, so we will write as it is. Again, on the other matrix also, I should do the same division by minus 1. That is going to be 2, 0, minus 1, 3, 1 and 0. and A is as it is. After this, according to the steps which we discussed, we have to make these two as 0 by making use of the one which we created by division. So for that, I should write R1 gives R1 minus 3 times of R2 and R3 gives R3 minus 9 times of R2. See, in both the places I am making use of the one which we created, that one which is present in the R2. Even in the previous one, we made use of the one which is present in the A11. That's why these both are R1. So, if I follow this, here row 1, that is 1 minus 3 times of R2, that will give 1 here, and this is 3 minus 3 times of 1, so that is going to be 0, and minus 2 minus 3 times of minus 4, that is going to give us 10, because this is 12 minus 2. Okay, so I'll rub this. So whatever the subtraction we make, I just write below the given row operation so that we can understand it easily. In the same way, R2 we are not going to do anything, so I am writing it as it is. Then R3 I will write it here, 0 minus 9 times of 0, which is going to be totally, this is 0, then second element 9 minus 9 into 1, that is also again going to be 0, then minus 11 minus 9 times of minus 4, so which is nothing but minus 11 plus 36, which is 25. So I completed one part, and the next part, the same row operation we do, write it here, row 1. So what will happen? 1 minus 3 times of 2, that is going to be minus 5. Then the next element, both are 0, so it is going to be 0, then 0 minus 3 into minus 1, so totally it is going to be 3. So I finished row 1 completely on both the matrix, and row 2 we are not doing any row operation, so we have to copy as it is 2 0 minus 1, and the row 3 again, which is 3 minus 9 times of 2, which is going to be minus 15, that is 3 minus 18, which is minus 15, then 1 minus 9 times of 0, so that is going to be 1 only, and 0 minus 9 times of minus 1, so total is going to be 9, and into A as it is. Then according to the steps which we discussed, we have to concentrate on this element. We have to make this as 1. That can be done by dividing the entire row by 25. After making that, we have to make these two as 0 by addition or subtraction. Okay, fine. Now R3, that is R3 divided by 25. So row 1, 1, 0, 10, row 2, 0, 1, minus 4, then 0, 0, 1. That is equal to, again here minus 5, 0, 3, 2, 0, minus 1. If I divide minus 15 by 25, that will give minus 3 by 5 after cancelling with 5 table. This is 1 by 25 and this is 9 by 25 into A. After this, making use of this 1, I have to make zeros above. So for that, we can do R1 gives R1 minus 10 times of R3. Similarly, R2 gives R2 plus 4 times of R3. See, again I am making use of the R3 that is having 1, which we created by division. So if I do this, R1, that is 1 minus 10 into 0. So that is going to be 1 only. Okay. So this is 1. Then 0 minus 10 into 0. So this is going to be 0. Then again 10 minus 10 into 1. That is going to be 0. So totally R1 we have done on the first matrix. Okay, and moreover you can also notice one more thing. Whenever we create zeros and 1 here, it will never change. So if you know this concept, you can directly write everything instead of calculating. See, and anyway this is 1. So as I told, 0 and 1 which is created here will never change because of the other row operation. And anyway this is also going to be 0. That is equal to, then here I have to calculate. So on this side, we are going to do R1 minus 10 times of R3. So I'll calculate here, then I'll copy the value. See, R1 which is minus 5 minus 10 into minus 3 by 5. So totally minus 5 plus 30 by 5, which is going to be 6. So totally it is 1. Then the next one is 0 minus 10 into 1 by 25. That is going to be minus 2 by 5. So I rub all this calculation part. Minus 2 by 25. Sorry, minus 2 by 5. Then the third one, 3 minus 10 into 9 by 25. So after cancelling this, this is 2 and 5. If you take LCM, 15 minus 18 by 5, which is minus 3 by 5 here. So you can do all the calculations in the rough and you can copy the values alone in the matrix. Then R2, again R2 plus 4 times of R3. So what will happen? R2 is 2 plus 4 times of R3, which is minus 3 by 5. So totally after taking LCM, 10 minus 12 by 5, which is minus 2 by 5 here. Okay, and then the next one is R2 plus 4 times. So 4 by 25 here. Then minus 1 plus 9 by 25, which is going to be minus 25 plus 9 by 25, which is so here it is minus 1 plus 4 times of 9 by 25. So that this is 36. So we get 11 by 25. Then after this, R3 we are not doing anything, so we will copy as it is. So let me write it here clearly. The final answer is, here we got 1 0 0 0 1 0, 0, 0, 1. And on the other side, after doing all this row operation, we get 1, minus 2 by 5, minus 3 by 5, again minus 2 by 5, 4 by 25, 11 by 25, minus 3 by 5, 1 by 25 and 9 by 25 into A. And this is going to be our inverse. That is, therefore, you are given a matrix and the inverse is this. Okay, if you want to verify, you can multiply A and A inverse and you have to get the identity matrix. If you have time, you can do this in the rough and you can verify whether the inverse which you got is correct or not. So again, I'll tell you the steps. So they have given a general form. Suppose if it is A11, A12, A13, then A21, A22, A23, A31, A32, A33. First, make sure the leading diagonal is non-zero. If it is 0, then you interchange some rows or columns so that the 0 is not present in the leading diagonal. After making this non-zero, make this as 1 by division, and making use of that one, make these two as 0. The same thing you follow for the next column, that is make A22 as 1 by division, making use of that one, you make these two as 0. And again make this element as 1 by division and make use of that one, making use of that one, make these two as 0. So ultimately in one side we will be getting 1 0 0 0 1 0 0 0 1, and at the same time whatever matrix present here will become the inverse of the given question.